as it is the conjugate of a weak base. So actually, according to Brownstein-Lowry theory of acids and bases, the conjugate of weak base is strong, and conjugate of strong acid is very weak. So like that, in these salts, only cationic part. In these salts, only cationic part will undergo hydrolysis because cation is active or strong, as it is the conjugate of weak base. For example, so NH4Cl. Let us consider a salt like NH4Cl. So in this NH4 plus is the cationic part of this ammonium chloride, is undergoing what now? Hydrolysis to form what? Ammonium hydroxide plus H plus. H plus. So ammonium plus water gives rise to NH4OH plus H plus. So when ammonium chloride is dissolving in water, you will getting a solution which is acidic in nature because it is producing what now? H plus ions, acidic in nature. So this is very, very important. So question is like this now. Aqueous ammonium chloride solutions are acidic. Solutions are acidic. Why? Because in aqueous ammonium chloride, cation of the aqueous ammonium chloride, this is the cationic part of the salt, is undergoing what now? This is the hydrolysis. NH4 plus water gives NH4OH plus H plus. Why not Cl minus is not undergoing the hydrolysis? Because it is the conjugate of strong acid. Strong acid conjugate is weak. That's why Cl minus never undergoes hydrolysis. Only this part of the salt is undergoing hydrolysis. Therefore, aqueous ammonium chloride solutions are acidic in nature because of in aqueous ammonium chloride cationic part is undergoing hydrolysis to form what now? H plus in the solutions. If H plus is forming in the solution, means the solution is acidic in nature. So therefore, aqueous ammonium chloride solutions are acidic. Why? Because they will producing what now? H plus ions in the solution. That's why what? Their solutions are acidic in nature. So this is the cationic hydrolysis. Next, second, it is anionic hydrolysis. So what is meant by anionic hydrolysis? This is the anionic hydrolysis. Suppose examples of these salts. For example, CH3COO Na. This is the sodium acetate, and this is HCOO Na, and these are the salts. For example, these salts undergoing what now? These salts undergoing only the anionic hydrolysis. Only anionic hydrolysis. So this part is only undergoing hydrolysis, not this part. These are the salts are forming by mixing what now? Weak acids plus strong bases. So this is the weak acid and this is the strong base. So by mixing weak acid and strong base, you will getting a salt like CH3COO Na. In this, only the anionic part, CH3COO minus, is undergoes hydrolysis. So by undergoing hydrolysis, this is the anion of the salt is undergoing what now? Hydrolysis. Now you will getting what? CH3COOH plus OH minus. So in the solution, you will getting what now? This type of ions means basic in nature. So aqueous solutions of these salts of weak acid and strong base are basic in nature because they are producing what now? OH minus in the solution. OH minus in the solution. So this is the anionic part. Anionic part of the salt is undergoing hydrolysis. So CH3COO minus Na plus HCOO Na. These are the salts of weak acid and strong base. In this salts, only the anionic part of the salt is undergoing hydrolysis because anion is the conjugate of weak acid. So why anionic part undergoes hydrolysis because anion, that is CH3COO minus, is active in this case. Active or it is stronger, as it is the conjugate of weak acid, that is CH3COOH. That's why only this anionic part is undergoing hydrolysis. So in this CH3COO minus is undergoing hydrolysis. In this HCOO minus is the anionic part is undergoing hydrolysis. So this is nothing but what now? Anionic hydrolysis. And the next it is third, it is cationic and anionic, both hydrolysis. Cationic and anionic hydrolysis. So what of the salts of so for example CH3COONH4, it is a salt of what now? Salt of weak acid, and this is the CH3COONA. This is NH4. CH3COONH, ammonium acetate. So it is a salt of weak acid and weak base. Weak acid is a mixture of weak acid and weak base. Suppose HCOONH4 and AlCH3COO taken twice, etc. These salts in which both anionic as well as cationic parts. So this is the cationic part is undergoing hydrolysis, and also this NH4 plus is also undergoing hydrolysis. Both undergoes hydrolysis because they are the conjugates of weak acid and weak base. They are very strong. That's why they undergo hydrolysis. For example, so CH3COONH4. So in which we have what now? Acetate anion is the strong. That's why undergoes what now? Hydrolysis to form what? CH3COOH plus OH minus. And the second part, it is the ammonium plus. Ammonium plus also undergoes hydrolysis to form what? NH4OH plus H plus. Therefore, CH3CO minus is undergoing hydrolysis to form what now? OH minus in the solutions. And ammonium ion also undergoes hydrolysis to form water NH4OH along with H plus ions. Therefore, they contain both H plus ions and OH minus ions. Therefore, their pH is depending on the K and Kb of these salts. K and Kb of the weak acid and strong base. Weak acid and weak base salts now. So this is about what now? Cationic and anionic hydrolysis. CH3COO and H4. This is the ammonium acetate. This is ammonium formate. This is aluminium acetate. This type of salts will undergo both cationic as well as anionic hydrolysis. So now we'll discuss about the pH of these pH and pOH of these salt hydrolysis. pH and pOH of these salt hydrolysis solutions. So let us first is the salt of weak acid and strong base. Salt of weak acid and strong base. There are 4 different types of mixture of salts. One is a weak acid and strong base. Second is the strong acid and weak base. And third is the weak acid and weak base. And fourth is the strong acid and strong base. There are four different types of solutions. There are four different types of salts. By mixing there, you'll getting the different type of salt mixtures. So now we are going to discuss about the hydrolysis of salts of weak acid and strong base. So what are the examples to this weak acid and strong base? For example, weak acid CH3COO and strong base is the NaOH. Therefore, by mixing this, you'll getting the CH3COO Na and HCOO Na. Next, AlCH3COO taken twice, etc. Or magnesium chloride also. Magnesium chloride. Magnesium hydroxide. Magnesium hydroxide plus HCl. You're getting the MgCl2. MgCl2. So this is so these are the salts. Actually, what about the cation? This is the anionic CH3COO and HCOO. So now salt of weak acid and strong base hydrolysis. So examples CH3COO, HCOO, aluminum acid, etc. So now, so in this CH3COO minus, that is anion of the salt. Anion of the salt undergo hydrolysis. Undergo hydrolysis. This is the anionic hydrolysis. Suppose CH3COO minus plus water. You're getting the CH3. This is an equilibrium reaction. So CH3COOH plus OH minus. CH3COO minus plus water gives rise to CH3COOH plus OH minus. So its solution is basic in nature. Therefore, pH is greater than 7 for this kind of salt hydrolysis solutions. So this is an equilibrium. Therefore, K is the equilibrium constant. So it is equal to CH3COOH into OH minus square bracket by CH3COO minus into square bracket water. So where K is the equilibrium constant. This is the equilibrium constant in terms of molar concentrations. See, this is constant. Molar concentration of water is constant at constant temperature. This is also constant. Therefore, K into square bracket water, it is also another one constant, that is the KH. KH is the hydrolysis constant. Salt hydrolysis constant. Salt hydrolysis constant. So it is equal to what? CH3COOH into square bracket OH minus by acetate ion CH3COO minus. So this is equation number 1. Now this is the salt hydrolysis. KH is equal to salt hydrolysis constant. KH is equal to acetic acid square bracket into OH minus square bracket by CH3COO minus acetate anion square bracket. This is equation number 1. And second, it is ionization of water. So in this we have various terms. So this is the one term, and this is also, this is the acetic acid is the one. We want what now? We want to calculate the molar concentration of acetic acid. So therefore, now we are going to determining the ionization of acetic acid. Ionization or dissociation of acetic acid. Dissociation of CH3COOH. So how can we calculating this? So CH3COOH when dissolved in water is undergoing hydrolysis. CH3COO minus is undergoing ionization. CH3COO minus plus H plus. This is the ionization of water. So it is a weak acid. So weak acid ionization when dissolved in water, acetic acid is dissociates into acetate anion plus H plus. So let us applying equilibrium. This is an equilibrium. Therefore, equilibrium constant K is equal to acetate anion into H plus by acetic acid into H2O. So similarly, this is also constant and K is also constant. This is an equilibrium constant, K equilibria. So K equilibria into molar concentration of water, both are constants. It is equal to acid dissociation constant, that is Ka, because it is a dissociation of weak acid. So Ka, it is a acid dissociation constant. Acid dissociation constant. So Ka is equals to acetate anion CH3COO minus into H plus by CH3COOH. So this is equation number 2. This is equation number 2. So now here we are calculating what now? First the hydrolysis constant, which is equal to acetic acid square bracket into OH1 square bracket by acetate anion square bracket. Now this is the dissociation or ionization of acetic acid. So when acetic acid dissolve in water, you will getting the acetate anion and H plus. This is the dissociation of only the acetic acid. So now by applying equilibria, K equilibria is equal to this one. So this is constant at constant temperature. This is also already it is constant. So constant into constant, another one constant, that is the acid dissociation constant. That acid dissociation constant is equal to this one. This is equation number 2. Now dissociation or ionization of water, because in the equation we have the terms of H plus and OH minus. Therefore, in order to calculate that one, we want to calculate the ionization of water. So water is ionizing into H plus and water, H plus and OH minus. So water is ionizes to H plus and OH minus. So for this, we already know that Kw, this is the ionic product of water. Kw is equal to square bracket H plus into square bracket OH minus. So this is equation number 3. By taking equation 1, 2, 3, from 1 to 3, from equation 1, equation 2, equation 3. So what is equation 1 now? So equation 1 is the equation 1 is this one now. So acetic acid concentration by OH minus concentration by CH3CO minus. So this is equation 1. This is the equation 2. So by from equation 1, 2, 3, you will getting the KH is equal to KW by KA. KH is equal to KW by KA, where KW is the ionic product of water. Ka is the acid dissociation constant. KH is the hydrolysis constant. So KH is equal to KW by Ka. So already we know that what now that one this is the anionic hydrolysis. So anionic hydrolysis. But how can we calculating this from this H plus ion concentration? So to calculate the H plus ion concentration, first you take CH3COO minus. Already it is this is the anionic hydrolysis of the acetate anion. Already we seen this CH3COO H plus OH minus. So at time t equal to 0, this is if you assume this as C moles per liter. You take C moles per liter of acetate anion, and this is in excess and need not to affect the equilibria. So, and this is at initially it is 0 moles per liter. This is also 0 moles per liter. After establishing the equilibria, T at T equal to equilibria. So you will getting what now? This is C alpha and this is also C alpha, and this is C minus C alpha. So initially this is how much na C moles per liter. Now from this C moles per liter, after the equilibria, you will getting the C, and also this is C. For 1 mole, you will getting the 1 mole of acetic acid and 1 mole of the OH minus. Therefore, it is C, it is C. But this will be what now? C minus some C. C minus, initially it is C. After establishing the equilibria, this will becomes what now? Alpha is the degree of dissociations. So alpha is the degree of dissociation. Alpha is the degree of dissociation. Therefore, you substitute this C minus C alpha. Actually, what is KH na? KH is equal to what? KH is equal to. So before in this we already this is the KH. This is the KH. Acetic acid concentration into OH minus ion concentration by acetate ion concentration. So acetic acid concentration. So KH is equal to acetic acid concentration is C alpha and OH minus ion concentration is C alpha by acetate anion concentration is C minus C alpha. So this is the KH. So what is KH now? This can be achieved from this equation, acetic acid concentration into OH minus ion concentration by acetate ion concentration. So KH is equal to what now? This KH is equal to C square alpha square by C into 1 minus alpha. So CC get cancelled now. So KH is equal to what? C alpha square by 1 minus alpha. So actually it is a salt of weak acid. Therefore their degree of dissociation alpha is also very, very less. Therefore alpha is very, very less than the 1. Therefore KH is equal to C alpha square. KH is equal to C alpha square. Alpha is equal to root KH by C from this. Alpha equal to root KH by C, where KH is the hydrolysis constant, alpha is the degree of dissociation. And next, we want to calculate the actually our aim. What is actually what is now? This is pH and pOH of these salt hydrolysis solutions. Therefore, in order to calculate the pH, so this is the basic solution now. This is what now? Basic solution. Basic means OH minus ion concentration is there in the solution now. So OH minus ion concentration is equal to what now? C alpha. Therefore, OH minus ion concentration, but OH minus ion concentration is equal to C into alpha. So OH minus ion concentration is equal to C into what now? That is KH by C. KH by C. So OH square bracket OH minus. So OH minus ion concentration is equal to, so by multiplying C and divided by C, you will getting what now? This is root KHC, root KH into C. By multiplying with C and divided by C, this OH minus ion concentration is what now? This is OH minus ion concentration is equal to square root KH into C. But KH is equal to what now? That is C alpha square. KH is equal to C alpha square. Alpha equal to root KH by C. But what now? KH is equal to KW by A now. So OH minus ion concentration is equal to under root KW by Ka into C. So by this you will getting the OH minus ion concentration is equal to OH minus ion concentration is equal to Kw by Ka. Kw by Ka into C. By applying negative log. By applying a negative log base 10 both sides, negative log of OH minus, negative log of OH minus is equal to negative log of base 10 Kw by Ka into C power 1 by 2. So this will be what now? This is POH. This is equal to POH. And this will be what now? This is minus 1 by 2 log base 10 Kw plus 1 by 2 log base 10 Ka and minus 1 by 2 log base 10 C. By expanding this, it will be minus of log base 10 Kw plus 1 by 2 log base 10 Ka minus 1 by 2 log C. So POH is equals to the minus log base 10 Kw is the pKw. Therefore, this is 1 by 2 pKw. And this is minus 1 by 2 pKa. Next, this is minus 1 by 2 log C. So this is the principle is using to calculate the POH of salts like CH3COO-Na. CH3COO-Na when dissolved in water, you will getting the basic solution. That basic solution POH is 1 by 2 pKw minus 1 by 2 pKa minus 1 by 2 log base 10 C. This is the POH of the salt hydrolysis of salt of weak acid and strong base. And the second, it is the next solution, it is second type of solutions. Salts of weak base and strong acid. Weak base and strong acid. So examples: ammonium chloride, ammonium nitrate, and ammonium sulfate. So aluminium hydroxide, aluminium AlOH taken twice is a weak base and HCl is a strong acid. By combining these, you will getting the AlCl3, MgCl2, etc. AlCl3, MgCl2. These salts are belonging to salts of weak base and strong acid. So in this only cationic part of the salt undergo hydrolysis. So what is cationic part? This NH4 plus only undergo what na hydrolysis. What hydrolysis na? Cationic hydrolysis. So that is NH4 plus water gives rise to NH4OH plus NH4OH plus H plus. So this is the, when NH4Cl dissolve in water, you will getting the solution in which we have what kind of ions na? H plus ion. Therefore, their pH is less than 7 because acidic. So pH less than 7 means acidic solutions, acidic in nature. Therefore, their pH less than 7. So this is the cationic hydrolysis. So it is an equilibrium. Therefore, equilibrium constant, it is equal to what now? NH4OH into square bracket H plus by NH4 plus and H2O. So this is equilibrium, but it is constant now because it is pure liquid. Pure liquid molar concentrations are also usually it is equal to 1 or unity, therefore it is constant. And K equilibrium, it is constant. So constant into constant, another one constant, that is what now? That is hydrolysis constant. KH is hydrolysis constant. So hydrolysis constant, this one into this one is equal to NH4OH and H plus by NH4 plus. This is equation number 1. This is equation number 1. Next, you take the ammonium chloride salt. Ionization of ammonium chloride. Ionization of this weak base, that is NH4OH, because it is there in the KH. Therefore, we want to calculate the square bracket NH4OH. So in order to calculate the NH4OH, first you have to take what? Ionization of NH4OH. So in order to calculate this KH, we want the square bracket NH4OH. What is NH4OH? It is a weak base. So NH4OH when dissolved in water, it is a weak base. When dissolved in water, you will getting the NH4 plus. It is undergoing what now? Hydrolysis. NH4 plus OH minus. So it is an equilibrium. That's why K equilibria, it is equal to what now? NH4 plus into OH minus by NH4 OH and square bracket water. So again it is constant and it is also constant, constant into constant, another one constant, that is the, this is for what, a weak base, therefore you must write what, na Kb. Kb is equal to what, this is the base dissociation constant, NH4 square bracket plus OH minus by NH4 OH. So this is the equation number 2. This is equation number 2. This is the base dissociation constant. And here in this equation we have also one H plus ion. Therefore, in order to calculate the H plus ion concentration, we know that, but also we know that H plus ion concentration into OH minus ion concentration. OH plus ion concentration into OH minus ion concentration. This is the ionic product of water. Ionic product of water, that is Kw. So this is equation number 3. From equation 1, equation 2, equation 3, this is the salt hydrolysis constant NH4OH square bracket into H plus ion by NH4 plus. This is Kb. This is the base dissociation constant. This is the ionic product of water, that is equal to square bracket H plus into square bracket OH minus. From 1 to 3, we can write it as, from equations 1, 2 and 3, KH is equal to Kw by Kb. KH is equal to Kw by Kb. What is Kb is this one, KH is this one, Kwd is this one. Therefore, KH is equal to Kw by Kb. And next, we already know that NH4 plus water, this is in equilibrium, cationic part of the salt is undergoing hydrolysis. That's why NH4 plus water gives NH4OH plus H plus. So let us at time t equal to 0, if you take this as C moles per liter, this is water, and it is at time t equal to 0, it is 0 and it is also 0 now. After establishment of the equilibria, this will be C minus C alpha, this is C alpha, and this is also C alpha. So this is C alpha, this is C alpha, this is also C minus C alpha. By consuming C alpha, the leftover amount of NH4 plus will be the C minus C alpha. Therefore, KH is equal to what now? Square bracket NH4OH into square bracket H plus by square bracket NH4 plus. Therefore, C alpha into C alpha by C into 1 minus alpha, or C minus C alpha. So CC get cancelled. Therefore, KH is equal to C alpha square by 1 minus alpha. But KH is equal to C alpha square, since alpha is very, very less than the 1. Therefore, KH is equal to what now in this case? KH is equal to C alpha square. KH is equal to C alpha square. Alpha is equal to root KH by C. Root KH by C. But we want to calculate the H plus ion concentration. So H plus ion concentration. What is H plus ion concentration? But H plus ion concentration, because ammonium chloride when dissolved in water, you will getting a solution which is acidic in nature. Their pH is, so in order to calculate their pH, first H plus ion concentration is what now? C alpha. C alpha. So H plus ion concentration is equal to C into KH by C. So this will be what now? This is root KH into C. By multiplying with C and divided by C, this C and this C get cancelled and one C will appear on the numerator. So this is the H plus. But H plus ion concentration is equal to what is H plus ion? KH is what now? Kw by Kb. So square root of Kw by Kb into C. So by applying negative log, minus log based on H plus, you will get the pH. It is equal to minus log base 10 and Kw by Kb into C power 1 by 2. So this will be what now? pH. pH is equal to what? Minus 1 by 2 log base 10 kW minus into minus plus, therefore 1 by 2 log base 10 kb minus 1 by 2 log base 10 C. So this will be pH is equal to what? This is the negative log base 10 kW is the pKw by 2. pKw by 2 plus 1 by 2, this is a minus. So minus of 1 by 2 pKb and minus 1 by 2 log C. So this is the pH of a solution of salt of weak acid and strong base. Not weak acid, strong base, that is the weak base and strong acid. Weak base and strong acid. So pH is equal to what? pKw by 2 minus 1 by 2 pKb minus 1 by 2 log base 10. So these are very similar. But the next it is that one, the third type, it is salt of weak acid and weak base. Weak acid and weak base. So what is meant by weak acid and weak base? Now weak acid examples are what? CS3COO NH4, HCOO NH4, etc. These salts are what now? Salts are weak acid and weak base. So this can be obtaining from CS3COOH plus NH4OH. So CSCOOH is the weak acid, NH4OH is the weak base. By mixing them, you will get in the CSCOO NH4. So it is a salt of weak acid and weak base. So this salt mixtures yielding what now? CSCOO NH4. And it is a weak acid, and their conjugate is the CSCO minus, is just stronger. That's why it is also undergoing anionic hydrolysis. And it is a weak base, their conjugate is the NH4 plus, that will also undergoing what now? Hydrolysis. Therefore both undergo hydrolysis in this case. But here it is a type of both cationic and anionic hydrolysis. Anionic hydrolysis. Actually, case 1, if Ka of acid is equal to Kb of base, so such type of solutions pH is exactly equal to 7. They are neutral in nature. Neutral in nature. For example to this one, it is CS3COO NH4. CS3COO NH4, because Ka of acetic acid is equal to Kb of NH4OH. Therefore, by mixing them, you will getting this salt. Its pH upon hydrolysis is equal to 7. That is equal to neutral. So CS3COO NH4, when dissolved in water, you will getting a solution which is neutral in nature, because Ka of acetic acid is equal to Kb of NH4OH. If Ka of acid is equal to Kb of base, that will be neutral, because their pH is equal to exactly 7. Example CS3COO NH4. And second case number 2. Suppose if Ka of acid is greater than the Kb of base, their pH is less than 7, solution is acidic in nature. So what is the CS3COO Na? Example. So what is Ka of acid and Kb of base? Here what now? Example of this one, it is acid dissociation constant is higher than the base dissociation constant. So in that case, pH is less than 7. So for example, CS3COO Na. CH3COO So in this case, not this one, no, this is CH3COO or SCOOK. Suppose HCOOK, SCOOK. So in this case, Ka of HCOOH is greater than the Kb of KOH. Therefore, pH is less than 7 in this case. And case 3 is if Ka of acid is less than the Kb of base. So in this condition, pH is greater than 7, solution is basic in nature now. Solution is basic in nature. For example, MgCN2. MgCN2 is the salt. So in this case, Kb of MgOH taken twice is greater than the Kb of Ka of HCN. So depending upon the Ka and Kb, their natures will be depicted. So if Ka of acid is equal to Kb of base, then pH is equal to exactly 7. If Ka of acid is greater than the Kb of base, pH is less than 7. If Ka of acid is less than the Kb of base, pH is greater than 7. That will be basic in nature. So let us discuss about the hydrolysis of this kind of salts and their pH. Hydrolysis of weak acid plus weak base. That is CH3COO NH4. CH3COO NH4. So in this, both the cation and anion will undergo hydrolysis. Therefore, first it is CH3COO minus plus water. You will getting the CH3COOH plus OH minus. And ultimately, similarly, NH4 plus water. Again, you will getting the NH4OH plus H plus. So both will form what now? This is the H plus and this will be the OH minus. So OH minus means what now? Basic in nature. Therefore, we have to calculate the POH. So what is the POH of the solution? And what about the H plus of the solution? pH. So for H plus, we have the pH as well as POH. For OH minus also, we have the pH and POH. Therefore, we have to calculate the both pH and POH for this solutions. So in order to calculate first what now? What about the K equilibria to this these two equations? By combining these two solutions, we have what now? Combine this one and this one and this one and this one, and also these two. So CH3COOH and NH4OH. By combining these two, CH3COOH plus into NH4OH and H plus into square bracket OH minus by these four parts, CH3COO minus and NH4 plus and the square bracket H2O power 2. So one H2OH, H plus OH minus, one H plus OH minus cancel now. Therefore, this means what now? This H2O into this K equilibria is also one another constant, that is the KH, that is the hydrolysis constant. So it is equal to what? CH3COOH into NH4OH by CH3COO minus and NH4 plus. So in this type of salts, both cation and anion hydrolysis, both cation and anion of the salt will undergo hydrolysis. Therefore, this is the equation number 1. So in this we have what now? This is the weak acid now, and this is the weak base. Therefore, we have to find the ionizations of these two now. So ionization of acetic acid. First acetic acid, CH3COOH. So CH3COOH when dissolved in water, you're getting what now? CH3COO minus plus H plus. So acid dissociation constant Ka is equal to what now? CH3COO minus into H plus, because K equilibrium into the square bracket water, it is equal to another constant, that is the Ka, that is the acid dissociation constant. Therefore, this one into this one by this one, CH3COOH. This is equation number 2. And like that, ionization of ammonium hydroxide also there now, ammonium hydroxide. So ionization of ammonium hydroxide. So ammonium hydroxide again, when dissolved in water, it will be dissociating into NH4 plus OH minus. So now Kb is equal to, this is the weak base, this is the weak base, and this is the weak acid. For weak acids we have the Ka, for weak bases we have the Kb, that is base dissociation constant. So NH4 plus into OH minus by NH4OH, because KH is equal to this one into this one by this one and this one. So KH into this concentration of water is equal to what? That is Kb, that is base dissociation constant, that is equal to equation number 3. And also in this we have what now? Acetic acid there, ammonium hydroxide there, and acetate anion, H plus 4 anions also there now. And again, ionization of water. So ionization of water. So water ionized to H plus and OH minus. Therefore, ionic product of water Kw is equal to what now? Square bracket H plus into square bracket OH minus. This is equation number 4. From equation 1, 2, 3, 4. From 1, 2, 3, 4, we can write it as, from equations 1, 2, 3, and 4. KH is equal to Kw by Ka into Kb. This is the one another constant. KH is the salt hydrolysis constant. This is the salt hydrolysis constant of what now? CH3COO NH4, salt of weak acid and weak base. So KH is equal to Kw by Ka into Kb. This is equation number 4. Now the important equation, how can we calculate the KH? So in the salt hydrolysis of weak acid and strong base, and weak base and strong acid, alpha is equal to alpha, that is the degree of dissociation, is directly proportional to the concentration of the solution. For example, this is now. So salt of weak base and strong acid. So what was that one? So KH is this one. So KH is directly proportional to C. KH is directly proportional to C. KH is or alpha is what now? Alpha is inversely proportional to square root of C in this case. Alpha is inversely proportional to square root of C. But in this case, your number. Okay. Yes. Not this. Yes. So from 1, 2, 3, 4, we can write it as what? KH. KH is equal to Kw by Ka into Kb. But in this case, KH, that is the salt hydrolysis constant, is not depending on the C under root square bracket C, similar to what that one salts of weak acid, strong base, and strong acid, weak bases. But here, what we have now, actually, by combining these two, you'll getting what? CH3, combining these two equations, CH3CO minus plus water or NH4 plus anionic part of the salt as well as cationic part of the salt, both will undergo what now? Hydrolysis. So CH3CO minus plus NH4 plus water. both cation and anion undergoing what now in this case? Hydrolysis. Therefore, it is what? CH3COOH, CH3COH plus NH4OH. CH3COOH plus NH4OH. Suppose at time t equal to 0, you take this as C moles per liter and this also C moles per liter. And this is the pure liquid water. It never affects the equilibrium constant. This is 0 at initially, this is also 0 at initially. After establishment of the equilibria, what will happen? This will be C minus C alpha, this also C minus C alpha, this is C alpha, this is C alpha. As per your chemical equilibria, already we know this thing now. So what now? You substitute these values in this expression now. What expression? KH. What is KH now? KH is equal to this one into this one by this one, this one. Now you substitute these values in this expression. What will happen? So acetic acid concentration is what now? C alpha. So this one is C alpha, this one is C alpha, this is C minus C alpha, this also C minus C alpha. So C alpha into C alpha by C minus C minus C into 1 minus alpha into C into 1 minus alpha. Because this is C minus C alpha, we can write it as what? C into 1 minus alpha. So this C and this C cancel. Therefore, KH is equal to what now from this? C minus C alpha, C minus 1 alpha, C minus 1 alpha. This is C minus C alpha. This is also C minus C alpha. This is C alpha. This is C alpha. So KH is equal to what now from this? C square alpha square. Okay.
Only yellow. Okay.
So again, I will explain this. Okay, so again I will. So CS3 COO minus plus NH4OH by clubbing these two equations, by mixing these two equations, CS3CO minus plus NH4 plus water. It will be what now? CS3COO H plus NH4OH. So at time t equal to 0, this is, if you assume this as C moles per liter, this also C moles per liter. This is pure liquid, no effect on the equilibrium. And this will be 0 at initially, this also 0 at initially. At t equal to equilibrium, after the establishment of the equilibrium, this will be what now? This is C minus C alpha. This also C minus C alpha. This is C alpha. This also C alpha. So by actually, what is our KH now? Acetic acid concentration is C alpha square. KH is equal to C alpha into C alpha. This is C alpha. This is also C alpha from this expression. By acetate anion concentration is what now? C minus C alpha. C into 1 minus alpha. And also C into 1 minus alpha. So this C and this C and this C cancel. Therefore, KH is equal to what from this? Alpha square by 1 minus alpha whole square. Alpha square by 1 minus alpha whole square. Therefore, KH is equal to what? KH is equal to alpha square by 1 minus alpha whole square. Actually, alpha is very, very less than the 1. It is very less. Therefore, KH is equal to what now? Alpha square. Alpha is equal to what now? KH. Square root of KH. But in the case of salts of weak acid and weak base, salts of weak acid and strong base, and salts of strong acid and weak base. What will happen? Alpha is equal to under root KH into C. Alpha equal to KH into C, or KH is equal to what now that one? Alpha square by C. KH is equal to what actually? Alpha equal to root KHC. But in this alpha never affecting on the equilibrium. alpha equal to root kh. Alpha equal degree of dissociation is inversely proportional to, is directly proportional to kh only. But in that case, alpha is directly proportional to square root c in that. But here c is not, c is missing in this case now. So alpha is equal to root kh. Alpha equal to root kh. Alpha equal to, but kh is what now? Kh is what? Kw by Ka into Kb. Alpha equal to square root of Kw by Ka into Kb. But actually, how can we calculate the H plus? H plus. What now? That is this H plus concentration, this H plus, this OH minus concentrations. H plus ion concentration into OH plus ion concentration, OH minus ion concentration, followed by pH and pOH. But how can we getting these values? Actually, what is this now? This is Ka. Ka is equal to what now? CS3CO minus into H plus ion concentration by acetic acid concentration. From this, we can get the Ka is equal to what now? So this is alpha. So how can we calculate the H plus ion concentration? So actually, Ka is equal to what now? From this Ka CS3COO minus into H plus by acetic acid concentration. So H plus ion concentration. So how can you get this one now? This is a previous equation. Okay. So Ka is equal to, how can you get this Ka now? So this is the previous equation now. Ka. So this is the Ka. So from this expression, we are calculating what now? H plus ion concentration. So this is the H plus ion concentration. So H plus ion concentration. So H plus ion concentration from this expression H plus ion concentration is equal to Ka into acetic acid concentration into acetate ion concentration. So what will be the acetic acid concentration now? So H plus ion concentration is equal to Ka into what is acetic acid concentration and acetic acid concentration by this is H plus ion concentration. This is only H plus ion concentration, not the acetic acid concentration. So now, so what will be the acetic acid concentration? So acetic acid concentration is what? Acetic acid concentration from this, where it is, yes, acetic acid concentration is this one. So this is the acetic acid concentration and this is the acetate anion concentration. Acetate anion is C minus C alpha and acetic acid is the C alpha. So from this, acetic acid concentration is C alpha. Acetic acid is the C alpha. So C alpha by C into 1 minus alpha. So C get cancelled. Therefore, H plus ion concentration is equals to Ka into alpha by 1 minus alpha. So actually alpha is very less. 1 minus alpha is very less now. So alpha is very less than the 1. Therefore, H plus ion concentration is equals to Ka into alpha. So now, what is alpha now? Alpha, we already know this now. Alpha is H plus ion concentration is equal to alpha Ka into alpha is what? Kw by Ka into Kb. We already deduced this equation now. This is the alpha. So now H plus ion concentration is equal to Ka into alpha. But in the previous cases, H plus ion concentration is equal to what? C into alpha. But in this case, this is similar, Ka into alpha. So H plus is equal to Ka into under root Kw by Ka into Kb. So from this, H plus ion concentration is equals to, so by multiplying and divided by Ka, you will getting what now? That is Kw into Ka. Kw into Ka by multiply and divided by Ka. So this will be Kb. By applying negative log, minus log base 10 H plus, because it is equal to pH. This is equal to pH. So minus log base 10 what now? Kw by Kb into Ka power 1 by 2. Therefore, this will be what now? This is pH. pH is equal to what now? Minus 1 by 2 log base 10 Kw minus into minus plus 1 by 2 log base 10 Kb and minus 1 by 2 log base 10 Ka. So by simplifying, pH is equal to what now? Minus log base 10 Kw is the pKw. Therefore, this is 1 by 2 pKw. And this is the minus 1 by 2 pKb. And this is plus 1 by 2 pKa. So this is the pH of the solution. This is what a pH of the solution. This is somewhat different from the previous two cases. pH is equal to 1 by 2 pKw. pKw actually it is equal to 14. 14 by 2 means 7. 7 minus something. 7 minus something means generally it is the pH of the acidic solution. So similarly, how can we calculate the pOH of the next solution? So what about pOH? So when ammonium plus, when acetate ion is dissolving water, CSOH is producing and OH minus. For this we have to calculate what na pOH. We already calculated the pH of this solution, NH4 plus water, giving rise to NH4OH plus H plus na. So now this one na. So Kb equal to what? Kb equal to NH4 plus into OH minus ion by square bracket NH4OH. So actually what is NH4 plus now? NH4 plus is C minus C alpha. By substituting C minus C alpha in this case, OH minus as usually you place it. NH4OH. NH4OH is a C alpha. This is C into C minus alpha. This is C alpha. This is Kb. This is OH minus. So by using that one, we will getting what now? OH minus followed by pOH. So this one is the what now? This is from third equation. We will finding what? pOH. pOH to this one. So Kb. What is Kb na? NH4OH. NH4OH. So NH4 plus is what concentration? NH4 plus concentration is the C minus C alpha. You place C minus C alpha at OH minus ion NH4 plus concentration. OH minus ion concentration is what now? You have to find this one only. NH4OH is what? NH4OH. Where is NH4OH? NH4OH is the C alpha. So here we have what? C alpha. This one what? C. This is C alpha. This is C. NH4 plus is the C minus C alpha. This is C minus C alpha. This is C alpha. From this, you calculate what now? Square bracket OH minus. Square bracket OH minus is equal to what now? This one into this one by this one. Therefore, OH minus ion concentration is equal to C alpha into Kb. OH minus ion concentration. So this is what now? NH4 plus water. You will getting the NH4OH. Not like that. Plus this one. NH4OH plus water. NH4OH plus water. NH4OH plus water, you will getting what? NH4 plus OH minus. So this is at T equal to equilibrium. T equal to equilibrium. Kb is equal to what now? This is NH4 plus into OH minus by NH4OH. So from this you calculate the OH minus ion concentration is equal to Kb into NH4OH by NH4 plus. So OH minus ion concentration is equal to Kb into what now? NH4OH. What is NH4OH? NH4OH. NH4OH is the NH4OH. So from the C alpha, this one C alpha, NH4 plus is the C minus C alpha. NH4OH is the C alpha. What happened now? Yes. NH4OH is the C alpha. This is C alpha and this is the C minus C alpha. This is C into 1 minus alpha. So CC get cancelled. Therefore, OH minus ion concentration is equals to Kb into alpha by 1 minus alpha. Actually, 1 minus alpha is very, very less. Therefore, you leave it this. OH minus ion concentration is equals to what now? That is Kb into alpha. Kb into alpha. But alpha equal to what? Kb is equal to what? This is the Kb. But how can we calculate the Kb? What is Kb now? This is Kb or Kh? Yes. Alpha equal to root Kw by Ka into Kb. Alpha equal to what now from this? OH minus ion concentration is equals to Kb into alpha equal to what now? Alpha equal to square root of alpha equal to square root of Kw by Ka into Kb. Alpha equal to square root of Kw by Ka into Kb. By applying negative log, minus log base 10, both sides, it will be minus. So this will be by multiplying divided by Kb. So it will be what now? That one Kw into Kb by Ka. This is so by applying negative log, this is equal to OH minus. So by applying negative log of this one, it will be minus log base 10 OH minus. This is minus 1 by 2 log base 10 Kw into Kb by Ka minus log base 10. Yes. This is equal to what now? POH. So POH is equal to minus log base 10 Kw minus log base 10 Kw minus 1 by 2 log base 10 Kb, and this will be 1 by 2 log base 10 Ka. So POH is equal to what now? This is minus 1 by minus log base 10 Kw is the Kw minus log base 10 Kw is the Pkw. Therefore 1 by 2 Pkw. Next this is minus log base 10 Kb is the Pkb. Therefore it will be what? This is plus 1 by 2 Pkb. And this is similar 1 by 2 pKa. So this is the POH of the solution of mixture of weak acid and weak base, hydrolysis. Upon hydrolysis of the weak acid and weak base, you will getting what now? H plus as well as OH minus. For H plus ions, we have the pH. For the OH minus ions, POH. From this again, pH can be calculated. Now pH is equal to 14 minus POH. So this will also we can calculating. So this one also. Actually, what is there in this now? This is again I will repeat this. This is the hydrolysis of weak acid and weak base. So weak acid salt, weak base salt. By mixing, you will getting what now? CS3COO NH4. So in this CS3COO NH4, we have the two parts. One is the anion part and another is the cationic part. So both the cation and anion are the stronger because they are the conjugates of the weak acid and weak base. So it is the conjugate of the weak acid, it is stronger or active. It is the conjugate of the weak base also, it is active or stronger. Therefore, both undergo what now? Hydrolysis. In this hydrolysis, one is producing OH minus, another is producing H plus. Therefore, we need to calculate what now here. Our aim is to calculate the pOH of pOH and pH of these solutions. This is forming what now? OH minus. This is forming what now? H plus. Therefore, for H plus, we need to calculate the pH. For OH, we need to calculate the pOH. So, by combining these two, you will getting what now? An equilibrium constant. That equilibrium constant is equal to equation number 1 because this one into this one, this one into this one. So, this is in the numerator and all these four parts are in the denominators now. So, K equilibria, it is equal to this one. And this concentration into this K equilibria. This is at constant temperature, and this is already it is constant. Constant into constant, it is again another constant. It is the salt hydrolysis constant. This is the KH. So you will get in the equation number 1 in this case. Now here we have what now? Square bracket acetic acid, square bracket ammonium hydroxide. Therefore, we need to calculate their acid dissociation constants. So when acetic acid dissolve in water, you will getting like this. For this Ka is like this. And also we have one more term, that is the NH4OH. So NH4OH when dissolved in water, you will getting the NH4 plus OH minus. So Kb is the base dissociation constant. This is equation number 3. This is equation 1, this is equation 2, this is equation 3, and also ionization of water, that is Kw is this one now. This is equation number 4. From equations of all these 1, 2, 3, 4, finally you will getting what now? Kh is equal to Kw by Ka into Kb. So this is some part. So after this, it is very important now. So acetate anion, by mixing these two, you will getting this equation now. By mixing these two, this one and this one, you will getting this equation. So at time t equal to 0, if you assume this as C moles per liter, this is assumed as C moles per liter. And that initially there is no formation of this acetic acid and this NH4OH, therefore you place it as what now? 0, 0. After establishment of the equilibria, some amount of acetate anion will consumed as acetic acid and some amount of NH4 plus also will consume to NH4OH. Therefore, this will be C alpha, this also C alpha, and the leftover amount is from C minus C alpha, this also C minus C alpha, where alpha is the degree of dissociation, that is the DOD. So now substitute these values, this C minus C alpha, this C minus C alpha, this C alpha, this C alpha in this expression now, this expression. So KH is equal to alpha square by 1 minus alpha whole square. Actually alpha is very less. Then 1 minus alpha is very less. Therefore KH is equal to what now? KH is equal to alpha square only. Alpha equal to root KH. Alpha equal to root KH from this. Alpha equal to root KH from this now. Alpha equal to root KH. Alpha equal to, but KH is what now? Already we calculated now, that is square root KW by Ka into Kb. This is alpha equal to this one. So we need to calculate what now? Actually H plus. So H plus is there in Ka equation, this equation. This is the Ka equation. So in this we have what now? H plus. In this we have what? H plus. Therefore you write H plus. H plus is equal to what now? This Ka into this acetic acid by acetate anion. So H plus is equal to Ka. Acetic acid concentration in the previous, this one. Acetic acid concentration is this one and acetate anion concentration is this one now. So you substitute this C alpha and this C minus C alpha in that expression. So in this expression now, H plus is equal to acetic acid concentration is the C alpha, acetate anion concentration is the C into 1 minus alpha. So H plus ion concentration is equal to Ka into this Cc get cancelled, alpha by 1 minus alpha. Alpha is very less. Therefore, H plus ion concentration is equal to K into alpha. From this H plus is equal to Ka, but alpha is this one now. You substitute this equation in this expression. So finally you're getting what? Expression concentration is equal to this one. So by applying negative log on both sides, we will getting this pH is equal to 1/2 pKw minus 1/2 pKab plus 1/2 pKa. So this is salt hydrolysis, and the leftover topic that is the buffer solution. So we'll meet in the next class now.
Yeah.
So any doubt, please ask.
ఇప్పుడు జరిగిన క్లాస్ లో ఎవరికైనా డౌట్స్ ఉంటే దయచేసి మీకు అన్మ్యూట్ ఆప్షన్ ఇవ్వబడింది. అన్మ్యూట్ చేసుకొని మీరు డౌట్స్ అడిగినట్లయితే సార్ మీ డౌట్స్ క్లారిఫై చేస్తారు. యా పరిగి గర్ల్స్ అన్మ్యూట్ చేశారండి. డౌట్స్ ఏమైనా ఉన్నాయా?
Yes, please.